This video is going to discuss angular kinematics. The objective is that students will be able to recite the equations and principles of angular kinematics. Properties of kinematics. Kinematics deals with the displacements, velocities, times, and accelerations of objects. This is true of angular kinematics as well. Angular kinematics deals with the displacements, velocities, times, and accelerations of objects that are rotating. In angular kinematics, angular distances are written as theta, which looks like, let me get the laser pointer out here, like that, the circle with the line in the middle. It's Greek letter theta. And distances are measured in units of radians. A radian is defined as the angle from the center of a circle whose arc length is equal to the circle's radius. So let's see a picture of that. Here we go. So if the circle's radius is r and the arc length is r, then that angle distance right there in the purple shaded region is 1 radian. That's the definition of it. And this turns out that there's 2 pi radians in 360 degrees, or 1 revolution. So one whole circle all the way around is 360 degrees, or 1 revolution, or 2 pi radians. They all mean the same thing. So we can use this fact to convert any one of these to any of the others. For angular speed and acceleration, we're going to talk about how fast things rotate, or the speed at which they rotate. That's called angular speed. Angular speed is designated by Greek letter omega, which looks like a curvy W, and has units that are radians per second, or written as rad per s. Angular acceleration is how the angular speed of an object changes as it revolves. So if something's speeding up its revolutions per second, then it's accelerating angularly. Like, think of a ceiling fan getting turned off and it slowly slows down to a stop. It's accelerating its rotation, or it's decelerating. The symbol for angular acceleration is Greek letter alpha, like a curvy looking lowercase a, and is measured in radians per second squared, or like this, radians per squared second. The time is still t, measured in seconds like it always has been. So, those equations from earlier in the year on kinematics, or what we'll now call translational or linear kinematics, where v was final velocity, v0 was initial velocity, a and t were acceleration and time, and x and xo were position and initial position. We're going to change all those into rotational formulas. So all the stuff's the same, like all the math is the same, the only thing different is the symbols being used. Greek letter omega and omega naught for final and initial angular speeds, alpha for angular acceleration, and thetas for angular positions. The good thing is the equations are the same. That's it for this video. The main point of this is we're going to use the same kinematics equations, just with updated rotational symbols and different units for distances, being radians instead of meters. And remember to take the quiz online. Thanks for watching.